Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. For exam P on probability, you were given that x is a random variable such that the second moment of x is 2 and probability that x is more than 0 is 0.8. Find the variance of x. And note that there are two answers that are not numerical. D does not exist, and E, no unique answer. And here's the solution. Consider a random variable x equal to 0 with probability 0.2 and equal to a positive number k1 with probability 0.4 and to a positive number k2 where k2 is more than k1 with probability 0.4. Then probability that x is positive is 0.8 and the second moment of x is 0.4 k1 squared plus 0.4 k2 squared. If we set this second moment equal to 2, then k1 squared plus k2 squared is equal to 2 divided by 0.4, and that's the same as 1 divided by 0.2, so it's 5. And so k2 is equal to the square root of 5 minus k1 squared. We assumed that k2 is more than k1, and this implies that k1 is less than square root of 2.5, which is approximately 1.5811. Also, the mean of x is 0.4 k1 plus 0.4 k2, because the value of 0 does not affect the mean. So the variance of x is equal to 0.4 k1 squared plus 0.4 k2 squared minus 0.4 k1 plus 0.4 k2, the whole thing squared. And after we square that second expression and cancel things out and so on, we will get 0.24 k1 squared minus 0.32 k1 k2 plus 0.24 k2 squared, and that's 0.24 k1 plus k2 squared minus 0.32 k1 k2. And we know the relationship between k1 and squared and k2 squared. We know that k1 squared plus k2 squared is 5, so this is 0.24 times 5 minus 0.32 k1 times the square root of 5 minus k1 squared. So that's 1.2 minus 0.32 k1 and square root of 5 minus k1 squared. For k1 equal to 0.5, the variance is 0.8513, while for k1 equal to 1, the variance is 0.68. So this shows that the conditions given do not allow for a unique answer. I just showed you a specific example of a random variable that can have two possible values of variance depending on the parameters, and everything else works just fine. That's answer E. Please remember this is copyrighted material. The problem itself was created by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.